Okay, so again, welcome back. Jackie and Courtney and Anna and Austin and Andrea and Frank and lots of other people. Um, this is again the probability time. And I want to go over the test. So, or the quiz, not the test. So let me do that. Okay, so here's the quiz. The first question is, write a paragraph that gives the pros and cons of using a histogram versus a box plot versus a stem and leaf plot for a presentation. Be sure to explain in what circumstances you would use each of these three charts and what circumstance you would not use each chart. Okay. There's some questions.
Hey Larry, your voice keeps getting really quiet when you get closer to the computer.
When you get close to the computer, that's interesting. It seems like it'd be the opposite. I'll try and like not move.
Okay, sorry.
Yeah, let me know
Thank
if you
you.
can't hear. Yeah, definitely let me know if you can't hear. I'll do my best. It's you know, technology is technology. So if we ever can get back to the college, if I can ever get back to the college, then I got my office computer that is much better technology wise, multiple screens, and good mic, everything good. I'm just on a little laptop now. So let's talk about histogram versus a box, a plot versus a stem and leaf. Okay, so what does a histogram tell you? What's the kind of highlight? What's the highlight of a histogram?
We can't hear you.
Uh-oh. Okay, can you hear me now?
It's better.
Okay, yeah, for some reason it was trying to log me out and I didn't do anything. And that happened. So yeah, definitely let me know if you can't hear me. I have no idea what happened, but it was trying to log me out. And I've been using Zoom a long time. Maybe it's some new Zoom feature or something. Okay, let's go back. As you can see, it says login there. Okay, nope, not there, there. Okay, so what is the main feature of what's the main thing that a histogram tells you the best? You can either say it or put in the chat box. What is the main thing that a histogram tells you the best? Want to start
Frequency. Oh.
The range of the data, actually the range of the data is best with a box plot. Because the box plot is very simple. It has a max and min and not much else. So the range is really easy to see with a box plot. Okay, the frequency. So the frequency, yes, kind of, but a little more information than that. It's really the distribution. So let me write that out. The histogram is best for looking at the distribution of the data, such as, is it normal? Is it unimodal, etc. Does that make sense? Okay, that's one good thing with the histogram. Another good thing about a histogram is that almost everyone knows how to read it. It is also practically universally understood. which is not true of the other two. Any questions about that piece right there? Okay. All right. What does it not tell you? What is the histogram not great for? Because it's, you know, it's not the best of everything, but it's the best for these things. Yeah, it doesn't. So then it does not. So from the histogram, one cannot see any individual data values. Because all you know is that between this number and this number, there was this frequency, but you don't know which numbers had the frequency, you just know a range. So that's kind of a main issue with the histogram, is you can't see individual data values. You also cannot see the quartiles. Okay, so you can't see the first quartile or the third quartile. Okay, just by looking at a histogram, you can guess, but you can't know exactly just at a quick glance. Any questions about the pros and cons of a histogram? Okay, now let's look at the box plot. So let's talk about what the box plot's good for. The box plot. What is the box plot good for? What's like the best piece of information to get out of the box plot?
Minimum and maximum.
Okay. It turns out that's not the best piece, but those are some pieces. So I'm gonna write. I'll write that down. That's not the number one highlight, but that's a good one. So clearly shows. Clearly. The minimum and maximum. Okay. Turns out so does the stem and leaf. Yeah, the middle 50% is the biggie. And I'm going to write even more important. It shows the, I'm going to say the interquartile range. And that is the middle 50%. Okay, so that's a biggie. The quartiles and the median. Any questions about what the box plot's good for? So it's really good if you want to find out what kind of the middle group is like. That's what the box plot's really all about.
Could you give an example?
Why you would use a box plot?
Yeah, like a situation where that would be helpful.
Sure. Let's suppose what you want to do is you want to decide you have a business, and since we're in Tahoe, let's suppose you have a bike rental business, since I just biked to Emerald Bay this morning and back, and you have a bike rental business, and you want to find out kind of what range of distances people go. Do they go all the way around the lake, or do they just go for a couple miles and not need much bike at all? Well, and you want to advertise. So your goal might be to advertise to that middle 50%, because you can't advertise to everyone. That's much harder. It's much better to have a focused advertising. So you often will advertise to that middle 50%, the interquartile range. And that would, so that knowing the box plot, you can actually see where that middle 50% is. Another one happens in nursing, okay, or doctor, medical. And that is something my brother does for a living. He actually delivers babies. That's what he does. And the middle, so the interquartile range, that middle 50%, means that you have a healthy, normal baby. Okay, if you're below the middle 50%, that's when you got to bring the doctor in and find out if they need special, attention, ICU, whatever. And if they're in the higher quartile, the upper quartile, then you might want to, help the woman maybe have to If you know ahead of time, you might have to give that woman a C-section, for example, because the baby's too big, and it could be damaging to the woman. Okay, does that make sense? So the
Yeah,
box plot would be
so
great for that.
so you can kind of make judgments off of it easier than you can with a histogram.
You can make judgments on the who's the middle typical group versus who are the outsiders. Does that make sense?
Yeah.
If you define the outsiders as the top 25% or bottom 25%. Does that make sense? Okay, so that's kind of why I use the box plot. But there's some cons. So the box plot, what does it not do? So what does it not show? Okay, it doesn't show individual points. I'm going to say data values. Okay, what else does it not show? Yeah, well, most can't read it. We'll get to that in a bit. It doesn't show the mode or the distribution. You can't look at a box plot and say, ah, that's a normal distribution, because you don't see that bell shape. Okay. And then two other issues, not about what it doesn't show, but other issues is one is most people do not know how to read a box plot. Okay. And also, box plots never work for large data. Well, actually, no, they do, sorry. So that's about it for there. Okay. So you got a problem is that if you do it in, a big presentation and you have just average people, then they're not going to have any idea what you're saying. Okay, now let's get into the stem and leaf. What does it show? So what does the stem and leaf show? Yeah, it shows the mode. Okay, and also one can retrieve the individual data values. From the stem and leaf. Okay, you can also see the shape of the distribution, because it really is a histogram. It's a special kind of histogram. Okay, why is it, what are the limitations of a stem and leaf? Yeah, most don't know how to read a stem and leaf diagram. Okay, and doesn't work for large data sets. Any questions at all on the answer to this one?
Could you give another example on a situation where you would use it?
We use stem and leaf. Okay, the stem and leaf, actually, I use it a lot. I use it when I'm looking at grades. So what I can do is I can do a quick little stem and leaf of your exam scores. And then because I grade a 98, 70, 60, I can easily see how many got A's, how many got B's, how many got C's, how many got D's, how many got F's, and also are they getting low B's or high B's? Does that make sense? Just by looking at the stem and leaf. So that's my use of it. Okay. All of these are for quantitative data, just a note. None of these work with qualitative. There was a question about the exam versus the quizzes. So the question is the exam just like the quizzes? And the answer is yes and no. So the exam will be on Canvas. So it'll be like this in terms of style. You're going to be using something called Proctorio, which means that it is going to be watching you. So there'll be a camera. You have to have a computer with a camera. If you don't, you can go to the college and get one, and for the entire quarter. And that way it'll be watching you, so you can't go and talk to other people about answers and stuff like that. That's the main difference, is it's going to use Proctorio. And the other main difference is it's going to be much longer. So this is a little 20-minute quiz, and my thought is you should all be able to finish in 10 to 15 minutes. On the other hand, the exam is more like a couple hours. Okay, I'll give you the full class time, but it'll be like a couple hours of exam. Does that make sense? So the biggest difference is length, because we're going to have a lot to cover instead of just one chapter. Okay, or one piece of a chapter like we'll have for the next one. Okay, any questions at all on question 1 of the quiz? Okay, let's go to question 2. Okay, consider the data below that depicts the responses of a survey that asked students how many times they went out on the slopes last winter. And here we go. We got 23, 38, 15, et cetera, I want to find the statistics. Okay, and I said you need to use technology. There's no way you want to do this by hand. I couldn't even do this in 20 minutes by hand. So forget that. But what you can do, let me double check. I have to log out and log in. I hope I'm still recording. Yeah, still recording. Yeah. So what we can do is put this into, I'll show you my spreadsheet program. You can use a calculator. You can use the books program, but you need to use some computer program type thing to get these numbers. So let me actually write them down on paper so that's memorizable. So we have 28, 38, 15. We have 4, 2, 69. Then we had 15, 0, 12, 0. And then we had 99, 33, 0. All right, so what I'm going to do is I'm going to go to the spreadsheet program. It's going to erase these numbers. I'm going to put in the numbers: 28, 38, 15, 4, 2, 69, 15, 0, 12, 0, 99, 33, 0. Any questions? Okay, and then I asked you for a bunch of stuff. Let's remind you: mean, median, mode, standard deviation. Okay, and we want to look at possible outliers. So the mean.
It should be 97, not 99.
Yeah, it was 97. Sorry about that. I'm trying to go really fast. Okay, so now what I do is I say the mean is 24. So I can write that down. Mean is 24.
28 should also be 23.
I have another one.
The top one.
23. Probably a quick reading typo. Yep. So it's 23.69. We have the standard deviation was 29.65. And then we have, what else do we want? We need the median and mode. So the median was 15. And the mode you should just be able to eyeball. I don't even know if it's in here. Might be or might not be, but you should be able to eyeball the mode. What is the mode of this data? Yeah, 0. There were 3 zeros and there was nothing else that was triple. So the mode is 0. We go back and type those in. So we have the mean is equal to 23.69. The median is equal to 15. The mode is equal to 0. And the standard deviation was equal to 29.65. Any questions so far? Okay, now notice it says use z-scores to determine if there's any outliers. If there's no outlier, if there are outliers, list them. If not, explain why you know there are no outliers. So what we're going to do is we want to look at the high numbers. So first thing on the low numbers, the minimum is 0. So let's go. And it says change it, but I actually do want it to be 0. And the z-score is negative 0.8. So note the z-score for 0 was negative 0.8. So 0 is not an outlier. So that means there are no low outliers. Is that clear? Because if 0 is not an outlier, then the next lowest can't be an outlier because the z-score will be even closer to 0. Okay, now let's look at the maximum. So the maximum was 97. So let's go find the z-score for 97. Okay, so is 97 an outlier? What do you think? Yeah, because notice the z-score is over 2, it's 2.47. So let's write this out. For the z-score for 97 was what, 2.47, I believe, which is greater than 2. So 97 is an outlier. Is it possible that there's more outliers? What do you think? Here's the data again. Okay. It's possible, but we have to check. So notice the next highest number is 69. So if I go in and find the z-score for 69, I get 1.53. So the z-score for the second highest, that's 69, is 1.53, which is less than 2. So 97 is the only outlier. Any questions at all on the quiz? Any questions? Okay, so no questions on the quiz. I want to mention a couple things. Thursday, one thing is we're going to be talking about project 1 on Thursday. So the hope is by Thursday, you all have partners. So remember, there's a project 1 discussion board. That's where you find partners. So try to make sure you have partners by Thursday, because Thursday we're actually going to be talking about the project. And it's a lot better if we're talking about it and you're with your partner, because then you have more reference on what's going on. Okay, so that is actually a big deal, is that project. It's a big part of the grade. So, don't take it lightly. Whereas these quizzes are a small part. I wouldn't say don't take them lightly. It's what you should make sure is you learn what's on the quizzes, but don't freak out if your score's low. It just means you need to study more for the test. Okay, any questions so far? Okay, I want to unshare my screen because I need to see all of you. And I need to see this chat box. That one? Nope. Okay, so now what I want to do is we're going to do some probability. And what I'm going to do is I'm going to use everyone in the room. And depending on how big your computer is, you may have to scroll to see all the names. And I am going to look at a couple of what we call events. So imagine randomly picking someone in the Zoom room. And I'm going to let event A be that the person's name begins in a vowel. Okay, and by the way, when I say the person's name, for example, we have an MD. Well, your name is MD, because we're just going to use what we can read, because I can't, we don't know it all, but we can at least see the names on the screen, and that's all we're going to go by is whatever's on the screen. Everyone's got a name there, and so don't change your name or all the probabilities are going to change. Okay, and let's let, I think that's copy and paste. Oh shoot, I did a private. The Zoom issue, it needs everybody. There we go. There we go. Okay, there we go. Let event A be the person's name begins in a vowel. And then what we're going to do is we're going to say event B just to make things pretty simple, be that the person's name ends in a vowel. Okay. And we need to define what a vowel is. It's a bit of a pain because actually I think we had someone. Maybe it's okay. So we'll just call vowels A, E, I, O, and U. A, E, I, O, and U. Sound good? Just so that we're all on the same frame. So now what I want to do is I want to say, what is the probability of A? Okay, what is the probability of A? So one of the things about probability by definition means the number that make the statement true divided by all the possibilities. So if we want the probability of event A, then it's going to be a fraction. So probabilities are fractions, and you need to remember that. Okay, whenever you have a probability, you write down a fraction. And then you could turn it into a decimal, that's fine. But by definition, probabilities are fractions. And the numerator, the number that make the event true, the denominator is all the possibilities that could happen. So now, let's see in the chat box if you can find the probability of A. A meaning that the person's first name starts in a vowel. For a person's name starts in a vowel. So let's see if you can see that. Okay, so one thing you need to do is you need to count all the people. It's actually kind of easy on Zoom if your computer looks like mine, because I see 4 across and 4 down. I don't actually count. 4 times 4 is 16. Any questions on that? Okay, that's the denominator. Then you go and now you have to go and count. You have to go and look at all the different names. Okay, I see an Anna, an Austin, an Yvonne. I use my fingers. So Anna, Austin, Yvonne, Adria, Erez, Lydia, and that's it. So there are 6. So the answer is 6 out of 16. Okay. Any questions on the probability of event A? Okay, this should be very quick. Find the probability of B. So see if you can do that. You know what the denominator is. That's a hint. It's really easy because we've already done it. So what's the probability of event B? And event B means, again, the person's name ends in a vowel. Let's see, you can put in the chat box. It's always best. 1 out of 30. I worry about 1 out of 3 because the denominator is 16. And nothing reduces to a 1 out of 3 if you have a 16 on the bottom. Yeah, I like the 4 out of 16 a lot better. Okay. And by the way, this is where it gets a little interesting. You are so used to being forced to always reduce denominators. That's not always a good idea. I think it actually tells the story better to say 4 over 16. Because it actually says, hey, look, there were 4 people. And let's go through, because someone said 5. Let me count. We have Jackie. We have Lizzie Dami. We have Lydia Trejo. And we have Christina Gove. So I just count 4.
I counted 8. We have Adria, Samantha, Anna.
So wait, let's look at it.
Courtney.
Okay, no, the whole name. The whole name. Anna is Anna. Sorry if I pronounced it.
Oh, sorry, I was just looking at first names. Okay.
You see that? Yeah. So we're looking at the name up on their window, and does it end in a vowel? Okay, and there are 4 of them. Okay, does that make sense? Okay, so that means it was 4 out of 16. Okay, and again, you could reduce a fraction. It's not necessary when it comes to fractions. Depends what you're interested in. If you're interested in telling the whole story, I think 4 out of 16 is better than 1 out of 4, because 4 out of 16 reminds you there were 16 people and 4 had a vowel at the end. But you could also do decimals and percent. So for example, you turn this into a decimal, you get 0.25, or percent is 25%. Okay, and you can use a calculator for that. Any questions on this example? Okay, let's look at let's look at some more. What is the probability of A and B? So it's the probability of A and B. Now what A and B means is that means that you've picked the person's name and both A and B are true. So now you have to count. And let's see if you can come up with that. Seeing a couple different answers. Let's see if everyone can get the answer. Okay, Yeah, it's 1 out of 16 because I see Lydia Trejo as the only person in the whole room that starts with a vowel and ends in a vowel. Is that clear? So the probability is not 1, it's 1 over 16. So remember, think of it as a fraction. Think of it as a fraction, so it's 1 over 16. Yeah, so we're talking about the name we're looking on that's shown on the screen, the entire name, start and end, to make life easier. Any questions so far? Okay, how about the probability of A or B? Now, first thing, what A or B means, that means if the first person's name starts with a vowel, great. If the first person's name ends in a vowel, great. If both happens, that counts. So either or both is fine. So again, you could do it with counting if you want, or you could do it with the formula, it turns out. So let me show you the formula. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And we've already come up with all three of these. So remember, this was equal to the probability of A, and that was 6 over 16, plus the probability of B. Probability of B was 4 over 16. And then minus the probability of A or B, A and B, and that was 1 over 16. Any questions on that? And then 6 plus 4 minus 1 is 9. So that's equal to 9 over 16. Any questions on this idea? Any questions? Okay. Again, the warning is it's very easy to watch me do it. But to come up with your own, that's a little harder because I'm going to give it in words most of the time. Okay. If the person name starts in a vowel, what is the probability that it ends in a vowel? Okay, the way we write that in symbols is now we're told the person's name starts with a vowel. And so we're given information, and that's going to change how we calculate probabilities. And because of that, that's going to be the probability that it ends in a vowel, that's B. And then we're going to use a vertical line segment, looks like that. And then we say given A. So sorry, it looks like that. You don't see it until I hit enter. Sorry about that. So that's how you write down what we call a conditional probability or a given statement. Any questions so far? Okay, and there's a few ways of doing it. One is to count. Okay, so the first thing is if you're given A, we're restricting the domain. We're only looking at the people who start with a vowel, and there were 6 of them. There were not 16. That means the denominator is going to be 6. Okay, and as Austin saw, the denominator was 6. The numerator amongst those 6, there was one person who finished with the vowel. So that's going to be 1 out of 6. Any questions on that? Okay, another way of doing it is using a formula. Probability of B given A is equal to the probability of A and B and A, or A and B, divided by the probability of A. And that probability of A and B, we already figured out. Probability of A and B was 1 out of 16. And then we have to divide by the probability of A, and probability of A was 6 out of 16. Okay, and 1/16 divided by 6/16 is 1/6. Okay, and you need to know how to do it both ways. Sometimes you'll only be given enough information to do it one of the ways. Any questions on this example? Okay, the next question is, are A and B mutually exclusive? Okay, so the first thing is we need a definition for that. So I want to give you the words first. So in other words, is probability of A and B equal 0? This is a very easy question. So mutually exclusive means the probability of A and B equals 0. Okay, so are they mutually exclusive? Yeah, definitely no. Probability of A and B was 1 over 16. And 1 over 16 is not 0. So A and B are not mutually exclusive. Any questions on this? Okay, notice the video is not going to show the chat, but I always say what I type. So when you're watching the video, you'll still be able to hear all the words of what's going on, even though you can't see.
Sure. Why does mutually exclusive equal 0? Why is it 0?
That's the definition. So the definition of mutually exclusive is you look to see if the probability of A and B is 0. If it's true, then you say mutually exclusive. If it's false, you say not mutually exclusive. Does that make sense? Okay, it's just a definition. And definitions are the kind of things you don't ask why it's true. You try to understand how to do it, but it's just a definition. It's just words. It's like, why do we call this thing in front of me a computer? Okay, well, it computes, I don't know. It's just a word. Does that make sense?
I'm getting too much into math theory, maybe.
We're not doing math theory. We don't do that in this class. I could get into that with you another day outside in office hours. Definitely not.
Oh, I don't want to. I was just saying that I'm
Oh, okay.
probably asking a question that's too complicated.
No,
It's
this is just a definition. These are just words, actually. There's more language than math theory. It's just the language that they use to say probability of A and B is 0. That's all it is. It's just a definition of a word.
Okay.
Does that make sense? So there's no advanced math on this. Later in this class, we're going to have lots of advanced math that we're going to just let the calculator do. Sound good? Okay, and we already had one on your quiz, and that was find the standard deviation. That is a complete mess if you had to do it without a calculator. And we just let the calculator do and don't worry about the math. Sound good? Okay. So the next question. Are A and B independent? Okay, again, we got another word. So independence has a definition. So you're not ready to say yes or no yet. Got to understand what it is first. So independence means and there are 3 different possibilities for independence. One is that the probability of A given B is equal to the probability of A. So what that says is if you're told that you know B, it doesn't change your answer at all. Okay, and 2, the probability of B given A is equal to the probability of B. So that says if you're told A, that doesn't change the chance of B. And then 3 is the probability of A and B is equal to the probability of A times the probability of B. Okay, and if you know one, if one is true, they're all true. If one is false, they're all false. Okay, just a note, by the way, see number 3? It's only true if they're independent. Do not use this formula unless you hear the word independent or if you know they're independent. So I'd say 35% of the people get taken points off on the exam because they use this formula thinking it's independent, and it's not independent in certain ways. Okay, so what we want to do is want to find out, are these true? And I think 1 and 2, if you got the information, number 1 and number 2 are easier than number 3. Because 1 and 2 only have 2 probabilities. Number 3 has 3 probabilities. So if you have a choice, go for 1 and 2. If you don't, if you only know the and you don't know the givens, then you got to do number 3. Any questions so far? Okay, now we already did the probability of B given A, right? The probability of B given A that was 1/6, if you remember. And we also did the probability of B. The probability of B was, if you remember, 4/16. Are those equal to each other? Yeah, definitely no. Okay, these are not equal. Since they are not equal, A and B are not independent. Okay, if you want 4/16 is equal to 0.25, you can always use a calculator or a computer to, plug in numbers. And then 1/6 is 0.17 about, and they're not the same number. There's different ways of looking at it, and that might be the easiest, is just stick in the calculator, look at the decimals, note the decimals are different. Because fractions sometimes can be the same even though they don't look the same, because maybe they reduce into the same. Okay, any questions at all on this example? Any questions? Not too bad so far? Okay, it's a lot of stuff, but it's important. Okay, so now we understand, hopefully, what probability means, always a fraction. We understand how to do probability of A and B, how to do probability of A or B, how to do probability of A given B, how to look at whether 2 events are mutually exclusive, and how to look to see whether 2 events are independent. Is that clear?
I've got a quick question.
Sure.
So A and B, they don't affect each other in this situation. Wouldn't that mean they are independent?
Okay, first thing is it's not they do, if you know A, that means the probability of B has changed. Do you see? Because so let me give you a real life example that I used and almost got killed for. I'm not kidding. I was a card counter in Vegas when I was young. And what I did is that I looked at things, decided whether events are independent or not. If they're independent, it doesn't help to count cards because it's not going to change your odds of winning. Does that make sense?
Yeah.
I figure we're in Tahoe, so you might have, thought about things like that. But if they're dependent, then you do want to make that calculation because it's going to change your odds and you're going to change your decision. Do you see that? So here they're dependent because if someone told you that their name starts with a vowel, now your probability of them ending the vowel has changed. You see that?
Gotcha. Okay.
Okay, it's actually smaller. The probability of them ending in a vowel given they started with a vowel is smaller than just general probability of end with a vowel.
Okay.
Because 1/6 turns out to be less than 4/16. Do you see that?
Yeah.
Yeah. So so it does change. Okay. These are, knowing one. I wouldn't say effect is probably not the right word. Knowing one changes the probability of the other.
Okay.
Right. Because I'm not changing any people. So changing the probability is what this is about. Is that totally clear?
Yeah, no, that makes sense.
Very good question. Let me give you an example of independence. I'm not going to do calculations, but you can probably imagine it. So let's let event A be the probability that a student in statistics has O positive blood type. Got it? And event B be the event that the person passes the class. What do you think? Independent or not? Yeah, those are independent. Blood type has nothing to do with whether you're going to pass a class or not. Okay. So if you have, say, AB minus, don't say, oh, I have no chance. No, has nothing to do with passing. You see that? So if they have nothing to do with each other, then they're going to be independent. Okay. But sometimes they do have something to do. But if you don't do the calculation, you can't know for sure. Okay. Again, I'm guessing they're independent. I've never calculated. I never, asked every student what their blood type is, but I can't imagine blood type having anything to do with passing this class. Do you agree? So those should be independent. Okay. Another one might be, and since I have this with me and I like to do that, so I'm going to pick a card. And let's say event A is the event it's a heart, and event B be the event that it's an ace. Are they independent or not? What do you think? Independent or dependent? So again, event A is that it's a heart, event B is it's an ace. So you can do the calculation if you want. Okay, what's the probability that it is an ace? Just as a fraction. Okay, 4 out of 52. There's 52 cards in the deck. Does that make sense? I'm seeing other denominators, but there's really 52 cards in the deck. I'm assuming there's no jokers. It's a standard, no cheating deck. Okay, so it's 4 out of 52 is the probability that is an ace. Okay. But if I tell you it's a heart, now what's the probability that it's an ace? Not 1 over 4, it's 1 out of 13. Right? There's 13 hearts, and one of those is the ace of hearts. Well, 1/13 and 4/52 are the same number. Okay, if you don't know, believe me. Sound good? So these are independent. Okay, so being a heart and being an ace is independent. And by the way, any questions at all on the card example? Okay, there was a request to take a 10-minute break, and I'm okay with that. Because this is a long class and I shouldn't make everyone sit forever. He meant to use the restroom or whatever. So why don't we take a 10-minute break? I got 20 after. we'll come back at 1/2 past. Sound good? Because I don't want to, sit here forever. So I'm going to even mute. And Okay, let's get back. It's 1/2 past. So we had our 10 minutes. And I think it's a good idea to take a break, and we would do that in a face-to-face class. And we have such a long class. Just to note, I made a mistake. I'm sorry about that. But if you watch this archived on YouTube, there'll be a 10 minutes of silence. I should have paused the video and then unpaused it, but I didn't do that. So sorry about that. But it's easy on YouTube or whatever to push it forward a little bit. Okay, what I want to do is I want to continue on this probability thing, and we're going to work out some problems. So let me share my screen. Okay, so now what I have is I have some problems for you guys, and these are probability problems. And what I want to do is I want to give you a little bit of time first to try it, and then I'll go over it. So let's look at 1A. So if you pick a letter at random from Lake Tahoe Community College, so imagine taking these letters, L-A-K-E-T-A-H-O-E-C-O-M-M-U-N-I-T-Y, U-L-L-E-G-E, throwing it in a bag, and then closing your eyes, picking one. What is the probability the letter is a vowel? Let's see if you can do that. So it shouldn't take, more than a minute or so. So let's see if you can find what is the probability that if you pick a letter at random from Lake Tahoe Community College, that is a vowel. Okay, and by the way, and I'll do this for you on this one, but I want you to do it also. So when we're talking about probabilities and you got these word problems, it's always a good idea to write it in symbols first. So P parentheses V. I'm going to go V for vowel. And that's the question. So I'm going to write P parentheses V equals question mark, and then let's see if you can work on it. So if you don't write it in symbols, a lot of times it's too hard. This one's not too bad. So probability of a vowel. Okay, and not the letter V, but a vowel. And A-E-I-O-U is what we'll call a vowel. Just in this class, we'll just do that. Okay. Let's see if we can get a few people answering. Different numbers, interesting. Okay, oh, got 3 different answers. Okay, so the first thing is definitely the denominator is correct. 25, and that's because if you count L-A-K-E-T-H-O-E-C-O-M-M-U-N-I-T-Y, Q-L-L-E-G-E, and you count that, you will count up to 25. So certainly the denominator is 25. Now what we need to do is count the vowels. So we just count it. In Lake, there's 2 of them. In Tahoe, there's 3 more. In Community, there's 1, 2, 3. So now we're on 12. And in College, there's 3 more. Okay. So how many do we have? How many total vowels are there? So Lake is 2, Tahoe is 3 more, then Community is 3 more. So that's 8. And then College is 3 more, that's 11. So the answer is 11 over 25, which some of you got. So the answer is 11 over 25. Any questions at all on part A? Any questions? Okay, let's see if we can work on part B. What is the probability if you pick a letter at random from Lake Tahoe Community College that it's an L given it's not a vowel? Let's see if you can answer that question. Okay, and what you want to do first is you want to write it. You want to write it as in symbols. So capital P for probability. And then you need to give a couple seconds to think about symbols, and then I'll write it, the symbols, and then we'll do it the numbers. Okay, so it's a probability of getting an L. It's a given. Remember, that was that little vertical line segment, not vowel. I'm going to go V for vowel. Since there's no confusion, there's no V's in Lake Dog College anyway, so we'll be all right. Okay. So that's what we want. Okay. So given it's not a vowel, and that's important. Okay. So what we want to do is want to say, well, let's look at the not vowels. How many not vowels are there? Well, if there's 11 vowels, there's 25 letters. 25 minus 11 is 14. So the denominator will be 14. Okay. Then among the not vowels, how many L's are there? Well, L's not vowel. So basically, how many L's are there? There's an L in Lake. There's 2 L's in college. So 3 out of 14. And a few of you got it. Took a few tries first. Okay. By the way, if you try it and get it wrong, you'll learn more than if you don't try it at all. So it's a good idea for all of you to give this an attempt and put it in the chat box. Don't feel embarrassed. Getting it wrong is a learning experience. You should feel embarrassed if you didn't put anything in the chat box, because everyone's going to look at you and say, "Oh, well, this person doesn't even pay attention." So again, try to put something in the chat box. Just even if it's your best guess, do your best, because then also I can look at it and say, where are people confused? Okay, let's look at part C. So now, what is the probability if you pick a letter at random from Lake Tahoe Community College? Then it's at the first half of the alphabet, that means A through M, or a vowel. So I always like to start doing it in symbols, probability of first half. I'll just call that FH for first half, or a vowel. Okay. Now we did have a formula for that. Do you remember the formula for or? Can you remember that? That was the probability of first half plus the probability of vowel minus the probability of first half and vowel. Okay, and I'm not sure if that's easier, but I want to remind you of that formula. Okay, and now let's go and look. So I want to mention, if you don't have a given question, a conditional probability question, the denominator is always just going to be the same big total. So the denominator has to be 25. So that's first thing is to note. The numerator, again, let's look at it. Well, we got the first halves, A through M. So I'm just going to go through and look at the A through M's. So we have L, L, A, K, E. All of those are the first half. Then we have A, T is not, A is H, and then E, and then C, M, M, and then I, and that's it. Any questions on that? And that's 11 of those, right? So it's going to be 11 plus the number of vowels, okay? And the number of vowels were 11 also, minus first half vowels. Well, first half vowels, that's the A, E's, and I's. Is that clear? And we have how many A's, E's, and I's? 2 in Lake, 2 in Tahoe, 1 in community, and 2 in college. That's 7, right? Any questions on that? Divided by 25. The 17, did I count wrong? On the first halves, you mean? Let me double check that. So on a lake, so lake, L-A-K-E, and then A-H-E, and then C-M-M, and then I, and then CLLEGE. Yeah, that is 17. Sorry about that. Much better. Yeah, I missed college. Okay, and what is 17 plus 11 minus 7? 21. So that's going to be 21 over 25. Counting could be hard, actually. Okay, even if you're experienced like me, counting a lot of letters and stuff is a pain in the butt. But what I'm very good at, which I not do showing you how to do, is to write a computer program to count for you. So that's how I would do it. But I'm not showing you that because this is not a computer programming class. Any questions at all on A, B, or C? Okay. Oh, I did want to mention something because something's going to happen this week. Today, I'm going to really try and do the whole time. So we're going to go until 25 after because I have to leave a little early on Thursday because I'm actually giving a statewide lecture on how to do online with the free materials for the whole California Community College system. I'm going to leave a little bit early on Thursday, so I'm going to go the full time this time and then a little shorter on Thursday. Okay, but not that short. We'll probably finish around this time on Thursday. Okay, so now let's look at it. Look at the next best. You like my embedded calculators in the book? Good, good. Yeah, that was a lot of programming. Fun though, I enjoy that. Okay, so if you pick 2 letters at random with replacement from Lake Tahoe Community College, find the probability that both letters are also letters of the word Monday. Okay. So let me tell you what this means first. So let me mention, I'm going to highlight it. With replacement is very important. So what that means is I'm going to pick a letter, I'm going to look at it, write it down, and then I'm going to put that letter back in the bag, mix the bag up, and then pick another letter. And that's called with replacement. So what that means is you can pick the exact same letter twice. Any questions on the idea? So first thing in symbols. And that is, we want the probability of, I'm just going to call this, maybe I'll call it M for Monday. Call it M1 and M2, where M1 means the first letter was from the word Monday, and M2 means the second letter was from the word Monday. Any questions on that? Okay, so now we got to find out what is the probability of the first letter being of the word Monday. So let's just work that out. So first thing is, what's the denominator? It should be really easy. What's the denominator? Yeah, it's going to be 25. We've already counted that a bunch of times, or a few times at least. So the denominator will be 25. Now we just have to go and count how many letters of Lake Tahoe Community College are in the word Monday. So M-O-N-D-A-s and Y's. So if you go and count and tell me how many. Okay, I'm getting different answers, so let's see if all of you can count. Give you a minute. I'm going to count 2. Okay, you all get different numbers than I am. All right, let's count together. Okay, so Lake is not, L is not, A is, that's 1. K is not, E is not. So we just have 1 from Lake. Okay, then Tahoe, we have A is, that's 2. And then O is, that's 3. E's not. And then from community, C's not, O is, M and M are both. So that's 6 so far. You know, and yes, I know, T no, Y yes. That's 8. C no. O yes. L L E G E no. So I count 9. So I see all of you wrote 8. Maybe I counted wrong, but I'm still getting 9. So Lake, let me do it one at a time. Lake has 1, has that A. Tahoe has an A and an O. Good. Someone else got 9. Then I'm not feeling so bad. I think there's 9. So 1 plus has an A and an O. That's 2 more. That's 3. And then O, M, M, N. So that's 4, 5 more. That's 8. And then 1 more. I'm counting 9. I think it really is 9. So 9 out of 25. Okay. Again, my counting skills are not better than your counting skills necessarily. So my math skills probably are, but counting is, like, we've been doing that since we were 4 or 5 years old. Okay. So here's the thing. Yeah, counting is hard. That's the first letter we pick. But here's the nice thing. If you're doing it with replacement, so I put the letter back in. If I told you that the letter was an O, does that change or does that not change the probability that the next letter will be of the word Monday? If I put the letter back in, what do you think? Yeah, it does not change. These are independent events. Whenever you're doing something with replacement, you have independent events, which means I could just multiply it by the probability the second letter is of the word Monday. What is the probability the second letter is of the word Monday? Looking for a fraction here. What's the probability the second letter is of the word Monday? The hint is it's really easy. Yeah, it's 9 over 25 again. By the way, 4 can never be a probability because that's bigger than 1. It's 9 over 25. Doesn't matter whether it's the first or the second, we're doing with replacement. Okay? 4-letter word, that's a whole different thing. All right? And if you want, that's 81 over 625. But you're not necessarily, you don't need to do that. Leaving this fraction's fine. On the computer, you'd probably have to get it as a decimal, give a bunch of decimals. Any questions on B, on A? Okay. Let's look at B. What's the probability the second letter is a vowel given the first is a vowel? What's the probability the second letter is a vowel given the first is a vowel? The hint is you shouldn't have to do any work. That's the hint. Here's more hint. So what's the probability the second letter is a vowel given the first is a vowel? It's not 100% chance. That would be 25 over 25. Yeah, it's 11 over 25 because it's with replacement. So the probability of M2 given M1 is just going to be equal to the probability of M2 because that is part of independence. Okay, that was, I remember it was number 1 or number 2, but either way, it depends on what you call A and B. But it was one of the independence formulas. And that's just 11 over 25. And that's it. There's nothing to do because we've already answered that. That's why I scrolled up here so you can see part A, which is the probability of a vowel is 11 over 25. Any questions on number 2? Okay, let's look at number 3. Okay, if you pick 2 numbers, two letters at random without replacement from Lake Tahoe Community College, find the probability that The second letter is an M, given the first is an L. What's the big difference about problem number 3 that's different than problem number 2? What's the big difference? You can say it or put it in the chat box. Yeah, without replacement. So I'm going to actually highlight without replacement. So this is what I mentioned about this particular chapter. You really got to pay attention to every word, because that with versus without changes everything. So now we're going to find the probability that the second letter is an M. I'll call that M2. Given is that vertical line segment. The first is an L. Call that L1. And that's what we want to find. Let's see if you can tell me what that is. Let's see, it's going to be a fraction. That's a hint. Okay, and if you know what to do, it's pretty quick, actually. So I'll give you a minute to think about it, and then we'll go over it. Okay, good. It looks like you're getting it. So let me go over it. So you got it, but at least those who put it in there. Let me explain what's going on here. So imagine you have this bag of letters. Remember, there are 25 letters in the bag. And what I did is I grabbed one of the letters, I looked at it and said, I have an L. And I take that L and I throw it over there. Now what I'm going to do is I'm going to pick another letter from the bag. What's the probability that letter is an M? And the idea is there's only 24 letters left in the bag because I threw that L out there. And throwing the L out there doesn't change the M's. There were 2 M's. That's why it's 2 out of 24. Okay, and that's 1/12, but I think 2 out of 24 tells the story. Any questions on part A? Okay, now let's look at part B. So now it's the first letter is an O or the second letter is an A. So let me write probability of O1 or A2. And I'll give you a minute or so to try this, see how you do. And again, it's always best if you put it in the chat box. Better to have something wrong in the chat box than have nothing in the chat box. And remember, the chat box is not recorded, so the world doesn't have to see your mistakes, yourself or whatever. Okay, so we got one person tried. We'll take a look. So other people, if you can jump on in. Okay. All right. I think I might need to do this one because it's actually kind of complicated. So remember, there was a formula, and that was the probability of A or B is the probability of A, which is probability of O1 in this case, plus the probability of A2, and then minus the probability of O1 given A2. And actually, I'm going to go the other way around. I'm going to go A2, a little easier to think about, given O1. Okay, you can do either order because O1 or A2 is the same as A2 or O1. Exactly the same thing. It's a little easier to think about it this way. Okay, so now we got to do these one at a time. So probably of the first letter is an O. Well, if you look at the O's, there's one in Tahoe, one in community, and one in college. That'll be 3 over 25. That's the first letter. Plus. Now, the probability of the second letter is an A. Put in the chat box. The probability of the second letter is an A. Put in the chat box. What is the probability of the second letter is an A? You can all put in the chat box. Okay, yeah, what I've found is about half of the people get this wrong. Okay, so let me explain what's going on here. I know nothing about the first letter. Okay, a letter was picked and yes, thrown out of the bag, but that doesn't tell me anything. Okay, it's kind of like I got these cards. Okay, and what I'm going to do is I'm going to take half the deck. I'm going to put them over here, and then I'm going to pick a card. What's the probability that this card is a heart? What can you tell me? Yeah, still 1 out of 4, or I'm going to say 13 out of 52. Even though I put half the deck over here, if you didn't see the cards that I picked, I just put them without telling you, then that doesn't change the denominator, right? Because it could be any of the 52 cards could be the one I've just picked because you have no information. So if you're not given information, the denominator doesn't change. So the denominator only changes on a given, which we'll get to in the third one. So for probability that the second letter is an A, there were 2 A's out of 25. So 2 over 25. And then minus, now we got to find the probability the second letter is an A, given the first is an O. And that does change things. And what is that? Oh, sorry, not given. I made a mistake on that. I apologize. That's and. Is the formula, not given. Had it backwards. What's the probability the second letter is an A and the first is an O? Definitely not 0, because I could have picked the O from college, for example, threw that out of the bag, and then picked the A from Tahoe. Okay, so this takes some work. So what we can say, this is the probability of A2 given O1 times the probability of O1. Okay, so that's an important little formula. It's a formula for the and. It's a probability of the second one given the first times the probability of the first. Okay. So that is equal to, first 3 25ths plus 2 25ths is 5 25ths. And then minus probability of A2 given O1, that's going to be 2 over 24. And then times probability of O1. And again, there were 3 O's. That's 3 over 25. Any questions on that? Okay, as I mentioned, this one was pretty complex. It was much harder than the rest of them. But everything here is probability from this chapter. So you are responsible for knowing how to do these. Any questions on that? And then you can throw in the calculator. I'm not going to waste your time. Hopefully, is it okay to assume you all know how to put arithmetic in a calculator? Okay. In fact, if you want, maybe I will waste your time. I'll show you the fun way. If I just go like that and I go to a new Google tab, I paste it. There it is. 0.19. So that's how I like to use a calculator. I just throw it in the Google tab. And it's 0.19. So let me go back. Okay, so why did I multiply by the probability of O1? Okay, so that's a formula. Let me write it down. Probability of A and B is equal to the probability of A given B times the probability of A. I'm sorry, of B. And that's also equal to the probability of B given A times the probability of A. So you can do either direction, in other words, of A. So those are formulas. I could prove them for you, but I tend not to prove math theorems in this class. I write down the formula and there it is. So those are good formulas to know. Notice that's different than the independence formula. Okay, this one always works, whether they're independent or not. So does that make sense? So that's why I had to multiply, because that's in the formula. Okay, there is a C. Let's do this. Okay, what is the probability both letters are E's? Let's see if you can figure that one out. So what is the probability that both letters are E's? So let me write it this way. It might help you. So that's the probability of E1 and E2. And the hint I have for you is that it's very similar to part B. Okay, it's similar to part of part B. So it's actually much easier than part B. So it's the probability both are E's. And we might want to scroll so you can read Lake Tahoe Community College because you need to see that. Let's see if we can find that probability. Okay. It looks like Lizzie fixed herself, which is good. Okay, so let's take a look. So what we've got is we can use that formula again. This is the probability of E2 given E1 times the probability of E1. Probability of E2 given E1, well, if one E was thrown out, we start with 4 E's, one from Lake, one from Tahoe, 2 from College. And we threw one out, there's only 3 E's left out of 25. Oh, sorry, out of 24 because we threw one of the letters out. And then we need to multiply that by the probability of an E1, and that's just going to be 4 E's out of the 25 letters for the first being E. Any questions on that? Any questions? Okay, so let's go to another kind of problem or another problem. Okay, let me ask you, are you familiar with what cards look like? Like how many cards in a deck and things like that? What an ace is, what a queen is, what a heart is. So anyone not familiar at all? Because I can't skip it if we're not. It's like you're familiar. Vegas, yeah, or Tahoe. Although, right now, what happens if you try and play in casinos? You'll go to a locked door because everything is closed. Yeah, so we're not playing the casinos. Okay. And I don't play in the casinos because they said they'd kill me. So I won't do that again. But I made a lot of money. So let's suppose we have a 52 card deck of cards. Okay, so there's a standard deck of cards right here. Okay. And the order of the cards does not matter in poker. So in other words, if you have an ace, 2, 3, 4, 5 of hearts, that's the same thing as having a 5, 4, 3, 2 ace of hearts. Okay, they mean the same thing with poker. So if you don't know poker, I'm telling you, that's true. And I haven't been a long time since I've taught this class, but I used to teach a class on statistics of poker and also statistics of gambling, which I'm not now. Okay. So what I'm going to do is we're going to look to see how many 5-card poker hands are there. Okay, so here's the problem. So for example, here's a 5-card poker hand. Okay, that's a 5-card poker hand. Okay, well, so is this one a 5-card poker hand. So here's what we're not going to be able to do. We are not going to be able to count all the 5-card poker hands like we did things like Letters of Lake Tahoe Community College. That you could actually count out. There's no way you can count all the 5-card poker hands. Instead, what we're going to do is realize what's going on. And that is we're starting with 52 cards and we're picking 5 cards. And we're looking at all the ways of doing that when order does not matter. And when that's true, let me show you what you can do. So let me go here actually. I think it's probably the best way. So I can show you how to get there. So what we can do is we can go to the textbook. And we can go to, we're in chapter 3. At least I think I programmed this guy. Now I gotta remember where I put it. That's the hard part. I think it's might be 3, 4, but I'm not sure. If it's not, it might be 3, 3. I didn't write the book, but I programmed the code in it. Nope, not that one. So I apologize for this. Shouldn't be in this one either. Might be in the first one. No, it's not in this one either. Sorry. Apologize for that. I should have looked ahead of time, but didn't. Here's probability. Well, I know I did it. Otherwise, we can go online and find it somewhere else. I'm having trouble finding which section it was in. It was in one of these. Because there's another way I can find it too. Okay, another way of finding it is you can go to just call calculate. Actually, how about combinations calculator? And what this is, Calculator Soup works, by the way, is we have n objects. How many objects are there to choose from this time for this example? 52. Just type in 52. And how many are we picking if we want a poker hand? 5. and we calculate. Okay, by the way, are there 2.598 ways of possibilities? Yeah, definitely no, definitely no. Because notice the E6, and that's really important. We've seen that before. It's actually 2598960, and that's the answer. So the answer to this is there are 2,598,960 different poker hands. Any questions on that? Okay, that's a lot, by the way. Notice there's no way you're going to be able to count them all like we did letters in Lake Powell Community College. It's not going to ever happen. Okay, you won't live long enough to be able to get through them all. But what we can do is we can do, and let me give you the notation. The notation in this case is going to be 52 C5. So what's the best way to prepare for the exams? And that is practice. That is practice. Oh, it's 52. I wrote 25. I said 52. Okay, that's what you call dyslexic typing. Okay, so the best way is practice. And the practicing, what you want to do is you want to, you could redo the quizzes, for example, look at the quizzes again. You can, and by the way, if you can't get them, you can always look them on the video. The videos have the quizzes too. You can go back to the MyOpenMath homework problems. You can work those out. And I'll have some practice tests also. So I think the best way to prepare for an exam is to do a lot of problems. Do a lot of problems that are similar to what we've done in class. So hopefully that makes sense. Okay, so now let's find the probability that a 5-card poker hand will be a royal flush. And a royal flush means ace, king, queen, jack 10, all of the same suit. So I want to remind you, this is very important, when you're doing probabilities, what do they always look like mathematically? Starts with an F. Yeah, fraction. Okay, so we're going to have a fraction. What is the denominator of this fraction? Not 52. Hint, it's very big. That's a hint, hint, hint. Yeah, it's this almost 2.5 million number. So the denominator is going to be 2,598,960. We've already done that calculation. We've got that. How do we get the numerator? The numerator is a number of ways that this could happen. How many different royal flushes are there? Yeah, there's 4, because you can have ace, king, queen, jack, 10 of hearts, of spades, of diamonds, or clubs. So the answer is 4 over 2,598,960. Okay, by the way, is this pretty likely or is this pretty rare? Yeah, exactly. Okay, so I'll let you know is, and I'm not a big poker player. I'm more of a poker studier, but I've never seen anybody get a royal flush on the first 5 cards. Okay, it is very unlikely to see it in your lifetime, just to let you know. Okay. On the other hand, how about getting a 4 of a kind? Is that less likely or more likely? Well, how do you get a 4 of a kind? What's the denominator first? What's the denominator? Yeah, it's the same denominator. There's no given here. Okay, so the denominator is still going to be 2,598,960. And now we're going to get the numerator. So you got to think about how many ways are there of getting a 4 of a kind. So what we need to do is we need to first pick what 4 of a kind it is. So for example, you could get 4 aces, 4 kings, 4 queens, 4 jacks, all the way down. And there's 13 of those, right? I'm gonna write 13 because there's 13 what most people think about their 4 of a kind. But let me show you something. Let's see if I can grab them fast. There it is. Okay, do I have a 4 of a kind in my hand? Okay, the answer is yes, but now let's do the following. Do I still have a 4 of a kind in my hand? Yes, but it's not the same 4 of a kind that I had before because I had 4 threes and a jack. Now I have 4 threes and a 9. So you can't just say 13 because for each of those 13, you got to think that there's a lot of cards left. In particular, there's 48 cards left. It could be. You need to multiply by 48. Sometimes you call this an multiplication principle. And then we divide by this big nasty number. Any questions on the probability that a 5-card poker hand will be a 4 of a kind? Okay. How about a flush? Flush means you get all the same suit. Okay, that's a tough one. So let's get the probability of flush. The denominator should be the same. That's that 2.5 million-ish thing. The numerator is a little harder. By the way, what's more common, a flush or a 4 of a kind? Anyone know? Okay. Okay, again, you're not expected to know this for sure, but probably a flush. And by the way, we're going to say a royal flush is still a flush. Okay. Okay, even though it's a special flush. So some of you say more 4 of a kind, some of you say flush. Let's get the probability you get a flush. So first you have to pick the suit because the flush could be hearts, diamonds, spades, or clubs. So that's 4 of those. Now, once you pick the suit, we got to pick 5 from that suit. How do we pick 5 from that suit? How many ways are there of picking 5 from a suit? How do we do that? And the hint is right there. This is a combinations problem because we're picking 5 out of the 13 cards in the suit. And we need to calculate that. And this is 1,287. Okay, so what we get, 4 times 1,287, I think that's what it was. Divided by the big ugly denominator. By the way, what's more common? The flush or the 4 of a kind? Yeah, flush is more common. Okay, 4 times 1287 is a much bigger number than 13 times 48. And you can stick it in a computer calculator and you'll see that's true. Okay, any questions on this example? Okay, so nice card example. Okay, being an expert poker player, it helps to really understand probability because that's how you do it. And you got to be able to read people's faces. I'm much more better at the probability than I am at reading people's faces. So. Okay, next is what does the law of large numbers say about the number of aces that you're going to get in a poker hand? So again, we haven't actually defined the law of large numbers, so let me give it to you. I didn't go to MIT. I went to UCLA. They worked together. I worked by myself. I worked with my brother a little bit, but mostly by myself. But my system was better than theirs. Working together was better, but actually my counting system was better than theirs. It's complicated though. Okay, very mathematical. But we had very similar stories. The movie's wrong. The book was right, by the way. Just let you know that. They never got hurt. They never got beaten up. That didn't actually happen. That was in the movie because they wanted to make it exciting. Okay, so law of large numbers. Okay, and what it says is that if an experiment is done many times with then the probability will likely be very close to achieved. There's a lot of ways of saying it, but this is basically it. So in particular, what does the law of large numbers say about the number of aces that you're going to get in a poker hand? But that means that if you play poker many times, the average number of aces per hand is likely to be very close to. And now, let's see, ERY. So now we're going to think about what's the probability. Well, what is, for any individual card, what's the probability that it's an ace? Yeah, 4 out of 52, okay, or 1 out of 13 if you want. So if you have 5 cards, that'll be 5 out of 13. And that's the law of large numbers. So it means that if you play a lot of times, it's very likely that your average is going to be what you would expect it to be. Just like if you flip a coin 1,000,000 times, what do you think your proportion of heads is going to be? See something easier than cards. If you flip a coin 1,000,000 times, yeah, it's going to be, it won't be a half. It'll be very close to a half. Do you see that? It'll likely be very close to a half. But it almost certainly isn't going to be exactly a half. But it's probably going to be like 0.4999998, something like that, or 0.500001. Okay, it's going to be very close to a half. Okay, and that's why we have it likely and close to. These are important words. Any questions at all on this problem? Any questions? Okay, we're reaching an end. I want to let you know we have more things to do. So what we're going to do in the last one, next time on Thursday, is I'm going to finish this worksheet. There's actually 7, I think, questions of worksheet. But we're not going to do that intro thing. So we should be able to finish the worksheet in not that much time. So we just did the longer problems. Okay, and it'll be a little bit shorter lesson on, so we'll have 5, 6, and 7. So we'll just have a little bit to do on Thursday. It'll be shorter, expected to be shorter. So today I went the full time, and I don't expect to always go the full time because that online is a little weirder. But what I've got now, I don't know if you know, let me stop the recording and stop the sharing.